Hello and welcome to the Deep Sea Podcast, Pressurised, a short, punchy version of our main feed that gets right to the scientific point. If you like what you hear and you'd like to hear the full episode, you can find it in the same feed. And now, to get right to the point.
Cast your mind back to 2021. It was one of those COVID trips, and I'd been on the ship for, at that point, 2 months. I had another month to go, and we just done the Philippines and the deepest shipwreck in the Mariana and all that kind of stuff, and we just taken the ship from Guam all the way down to Australia, and we were too early. So we stopped off in the North Australian basin, do some test dives and chuck some cameras down and see what's what. And one of the cameras came back with a big ray on it, big old ray, and it was just over 3,000 metres. So we started looking into this, and the deepest record, because as you know, I've talked about this a few times, I've got the spreadsheet of all the deepest whatever it is, and the deepest ray is something like 4,600 metres, but if you go to that paper, 99.9% of all the data they have in that paper is less than 3,000 metres, and there's one single ray that was caught on a trawl 1,600 metres deeper than every other ray in the world. So I'm not entirely convinced that's real, but it goes back to like the 70s or something, so I don't think there's any way of checking. But either way, it's an interesting thing because it ties in with our old boss Monty, who wrote that paper a long time ago about sharks and rays don't go deeper than 3,500 metres. So we were sitting here going, this is an interesting thing because that's probably the deepest ray ever confirmed by camera. So we had to go and find a fish specialist, and I believe it was the guy you spoke to who came back and says, I don't know what that is. It's a grey one.
Sometimes that's all you can do from an image.
Well, yeah, that's the problems with rays, isn't it? I think you got to turn them upside down, don't you?
And they hate that.
Yeah, that's my ray story.
There we go. Yeah, so to lead into that, we're going to go for a little bit of a creature feature run on the cartilaginous fishes. Of course, we all love the sharks, but we're going to try and branch out to the lesser known chimera and flat sharks, as I've started calling them after this interview, the skates and rays. So we're going to start off with an interview with Will White from CSIRO about the flat sharks, the rays and skates. I'm joined by Dr. Will White, ichthyologist at CSIRO, which is the Commonwealth Scientific and Industrial Research Organisation, which is basically Australia's national science agency. And Will focuses on the ecology, how they live, taxonomy, what they are, and biogeography, where they are, of sharks and rays, and has described over 50 new species of sharks and rays. So thanks for coming on for a chat, Will.
Thanks for having me on board.
We're glad to have you here. I feel like when we're talking in the deep sea stuff and in general, the skates and rays kind of get overlooked, I feel. They sort of miss out on the limelight when they're going deeper than a lot of the other elasmobranchs, and they're really nailing it down there, but they seem to be often overlooked.
Yeah, they certainly are. Ever since I started my work, they've always been that sort of overlooked, the flat sharks. And for many years telling people that they need some consideration too. And, there's a swing towards it, but they're still, nowhere near the amount of research compared to sharks.
The very first question is actually a listener question, but I think it's something I even struggle with because there are blurred edges. And at its simplest, it's what is the difference between sharks, skates and rays?
So, yes, sharks, skates, I always consider, when you talk about rays, I consider skates and rays in that one group, and how they differ from sharks is there's two main characters, one of which does fall apart at times, but in general, the gill slits sit on the bottom of the animal. So even on some of your flatter sharks, like the saw sharks, they still have the gill slits distinctly on the lateral side of the animal that you can see it if it's sitting on the seabed. In comparisons, rays, and a good example there is like saw fish, which is a ray and looks very similar to a saw shark, but they have the gill slits right underneath the head sitting on the seafloor. So if you ever have a group and you're not quite sure, position of the gill slits is the easiest way.
I've never had it explained so simply to me. That really helps.
The other one, which I think is good in some ways but does fall apart a little bit, is they call it the cephalization of the head. So where the head is actually a distinct unit from the pectoral fins. So in sharks, the head is separate to the pectoral fins, whereas in rays, they often form part of the, they sort of join into the head. But that does sort of fall away a bit with like the sawfish, the rays. You'd almost argue that their fins are quite separate and much more like saw sharks, and angel sharks are another one. So still a good character, but the gill slits you can't go wrong with.
Oh, I like that. That's solid. I'm relieved to hear that you tend to group rays and skates together, but that is sort of common parlance, isn't it? That doesn't map well taxonomically, but that's how we communicate when we're talking more casually. So how do you separate the two groups there, really?
Yeah, so the skates are quite distinct in that the pelvic fins, which are the two smaller paired fins just near the base of the tail, they're actually in two lobes on each side. So one is almost like a leg-like structure, almost like a finger that sticks out, and then the other one's almost just like a smaller pelvic fin. So they have these two on each side. So it almost looks like they got four separate things. And all it is during development, the pelvic fin structure just branches off into two separate entities rather than the one like the other rays have. That's the main character, which you can use to separate. Yeah.
Far easier than the rostral stuff, which gets really blurred in my mind.
No, definitely it does, because we all say they've got a hard rostral lobe, except for the 100 species that don't.
Yeah.
So it's not a good character.
And you have to shine a light for them to tell.
Yeah.
Or have a good molest of it. And sometimes they don't appreciate that.
No, exactly. Yeah. But yeah, certainly. The one thing it can get confusing with the pelvic fin, though, is that you do have the long claspers. So sometimes people have a glance and go, oh, yeah, it's got two lobes. It's like, well, actually, one's a clasper, the other lobe's right underneath. So it's not always the best character to be trying to determine. The good thing with them is that, the general shape of a skate is generally quite different in having a more pointed snout. But like anything, there's always a few exceptions which make it a little bit trickier.
Yeah, there's some really blurry edges. Those are the two best simplifications I've ever heard. So I'm really glad I brought them up, because I should be confident in this space, but it's just there's so many. You find yourself doing it's this except when it's this, it's this except when it's this, like a terrible key, which is always three except when there's not.
Oh, definitely. Yeah, no. And I mean, that's often the problem with some, especially some bony fish groups, is that, someone will ask you, how do you know it was that family? And sometimes you just go, I don't know. I just do. I've learned it, and I'm not sure what the actual character is, because some families are so diverse that all those characters fall apart at a certain point that are the most easiest to use in the field.
Yeah. A good gauge of how experienced someone is how confident they are.
Yes.
One of the analogies I use is if you ask a 4-year-old, what type of fish is this? It's either going to be a shark or a goldfish, and they'll tell you with complete confidence. If they and and scratch their head, then they're probably quite knowledgeable. Probably a taxonomist.
Yeah, exactly. Yeah. Well, that's the thing. As a taxonomist, you're about defining species, and yet the worst question a taxonomist faces is when someone says, "What is the definition of a species?" It's probably the most difficult question you ever get.
Even before we make a start, before we actually start talking about species, it's hard to define our own job.
Oh, exactly. Yeah.
Have they always been champions of the deep sea? Have they always made their niche going deeper? It feels like there's a lot relative to other deep sea groups. My job gets a lot easier because I've only got to remember about 7 fish.
Yeah.
Once you get to deep abyssal, there's not much down there.
Oh, the skates are certainly, they really do dominate those deeper waters. And I mean, even one of the species, so the abyssal skate, I think it is, the Bathyria richardsoni occurs down to around close to 3,000 meters. So, I mean, that's half of your problem is it's hard to even know some of the baseline information on these deep skates, like what they eat and things like that. Where in the shallows, we can actually do behavioural studies and actually examine them, like have cameras down, look where they are. The best we can hope for in some of those areas is, a fly pass with a tow camera, which is going to help you see where these animals might be in terms of habitat association, but you're not going to see behaviour in a, 2-second fly past.
No.
So, yeah, unfortunately, we just don't have a lot of information on most of those species.
And because of their sort of bottom association, they tend to be quite endemic, don't they? They tend to get themselves isolated on one side of a basin because they can't sort of swim up and over. And then we have a little bit of an issue where are these Atlantic species the same as what we're getting around here, or is that just what we're familiar with? Is it our science sort of ascribing them to a box we already have when actually they're quite different?
Yeah, I think what we're starting to see is that some of the, most of the skate species are quite localized and don't have big ranges, but there are a few of the deeper ones that are a little bit more pelagic. that they do potentially have this wider range. But even there, like one of the projects we're looking at is looking into egg cases in more detail. And one of the species that's being considered to be the same between the North Atlantic and down this way, the egg cases are quite different. And for every other species, the egg cases are very good determiners of, different species. So there's still a lot to know. And I think part of the problem is that in some aspects of science, you rely on genetics to kind of give you a bit of a hint as to where there might be, a species complex. But sometimes if the genetic data tells you that two things are just the same, often that's just based on mitochondrial DNA, which isn't really telling you contemporary data like what nuclear DNA data will tell you. So it can just gloss over a little bit of some of those cases. Like it works like 98% of the time, but that does mean that those other 2% do exist.
Yeah.
And we're sort of starting to find those now.
And that we're starting to find them in certain groups. Certain groups seem more conservative in those common barcoding regions.
Definitely, yeah.
And so it doesn't apply to everything. One area I wanted to touch on was reproductive methods, because there is a huge variety going on within this group of sort of, I'll just let you jump off with it actually. What are the forms of reproduction within the skates and rays?
One general statement right at the start is that what's amazing about sharks and rays in general is that they have higher diversity of reproductive modes than all other vertebrates combined, which is such a unique character of this whole group. Within the rays, the majority of species of rays are skates, and all skates are oviparous, which means they lay egg cases, and they lay sort of these rectangular egg cases with horns coming off each corner, so 4 horns. But they do vary a lot in size and texture and things like that.
I don't know if it's more of a UK thing, but we call them mermaids' purses. I don't know how international that is.
Yeah, mermaids' purses is one thing. Yeah, so that's quite a unique character amongst the skates. But then as you start to move into the rays, all the other rays are live bearers. So they'll have young which rely on the yolk. So guitarfish, for example, they'll have a large yolk sac, and the embryo utilises that yolk sac through to when it's about to give birth. One of the more interesting ones is like the stingrays and stingerees, and I think all the eagle rays and all that group, they have a yolk sac that the embryo utilises, but there's only enough for about half of the gestation. And then after that, they receive a thing called histotroph, which is like a uterine milk. But they have these long villi extensions that grow out of the uterine wall, and they'll enter the gill slits and mouth of the embryo and basically just release this milk that they then get nourished with.
I didn't know it was so direct. That's incredible.
Yeah, so they are. It's quite interesting. If you see one and there's an embryo inside, you cut open the uterus and all these little bits are going inside the mouth and everything. But they're all over, and then they sort of shed those at the end of a pregnancy. So you can actually tell whether an animal is recently given birth with the presence of these trophonomata, or these uterine villi that are there. So there's a lot more diversity within the sharks, because you get your egg eaters and embryo eaters, and there's also different modes of oviparity as well. So the egg layers. So within the rays, all the skates just have the short single oviparity, they call it, where each uterus they have 2 functional uteri, and they just produce an egg, and then like a few weeks later, a month later, they'll produce another pair of eggs, and they might lay up to 100 in a season.
Wow, there's massive difference to the morphology, because you can quite often ID a species by the egg case, but there's a reason for that. It's about where the eggs are laid and how they're tangling to whatever they're being laid on.
Yeah, so there's some species which have quite all this fibrous material on them, and that will it'll either attach onto some form of hard substrate, but other species they've worked out that they basically just trap sediment and then just acts as an anchor, so they'll still move around. So the big trick that these animals have, that embryos have in growing in egg cases, is that they still need oxygenated water going through them. So they can't just lay an egg case onto soft, muddy sediment, because they'll just clog up and they'll suffocate. And what's really interesting with skates is that when they're first developing, so when they're laid onto a substrate and it's just a fertilized egg and then the embryo starts to form, they have all this stuff they call like this jelly-like substance all around them, and it blocks up the horns. And that means there's no flow going on from the outside, so they're fully contained. And then as the embryo starts to grow, this jelly disappears and it opens up these little slits called respiratory fissures, which allows oxygen to come in. So it needs this flow of oxygen between them. So different species have different ways of laying the egg cases. So there's a recent study of a seamount off Tasmania here, where the tow camera work sort of showed, they were finding 1 or 2 egg cases semi-regularly. And then in this one patch of hard coral, deep seamount coral, there was just thousands of egg cases over a very short area. And so these skates, what they were doing was laying the egg cases amongst this coral. So that means that you haven't got any sort of soft sediment that's going to block up the respiratory fissures. They're also protected from predators. But it showed that this one particular seamount was an extremely important skate nursery area. And there's also one recently published, led by scientists from NIWA, where in the Ross Sea, they also found some skate egg nurseries down there as well. And that's another reason why it's really important to understand what species you're dealing with the egg cases, to be able to know what species are using these nursery areas.
Yeah, and gear all your protection around that. That's the sort of sense of urgency around it. There's a long job ahead of us figuring all this out, but at the same time, they are maybe being impacted right now. We need to understand what's going on. And if one particular seamount is a key nursery, you can really strike a blow to a species by going for it.
Definitely, and I think that's one of the things, is that having a look at whether an animal is caught and retained by a fishery or whether it's discarded is, a very minor part of the effect of that fishery on the species. And when I did my original honours research in Perth in Western Australia, we were going out on scallop trawlers and collecting samples of stingarees, which are the urolophids. They're sort of like stingrays, but they have a little caudal fin at the end and they're much smaller. They have about a 10 to 11 month gestation period with their embryos. But whenever they're caught in a net, they abort their young. It's like just a survival thing of like, I need to get rid of them so I can get away. So when the catch came up, even though these stingarees were discarded, you've lost 11 months worth of reproduction straight away. And they're synchronous breeders, so they mate at a certain time of the year. So every time one female was caught and it lost its young, that's a whole year until that animal can reproduce again, even though it was put back in the water.
Even beyond the stress and the damage of that, of actually being caught, there'll be a mortality associated with that. But even returned alive, you've reset that key reproductive female.
Yeah, definitely. It's the same as if you allowed a fishery to fish on a seamount and which destroyed the coral. You could almost wipe out a skate species from just removing where it lays its eggs straight away, and you wouldn't know.
Without ever harming an adult.
Yeah, that's it. Without even catching an adult, potentially.
Yeah, a risk of these locally distributed species and this mysterious ecology and reproduction where we only catch glimpses of it.
Yeah, definitely.
It's wild that we're finding these huge nursery grounds only now, and there's going to be plenty out there that we haven't seen yet.
Yeah, I'm sure there's probably a lot buried away in a lot of togue video footage and, various deep water video footage around the world as well. And I think as we start to get things like artificial intelligence and machine learning start to help sort of get through some of these, hours and hours of footage a lot quicker, I think you'll start to see a lot more detailed information can start to be collected. Because often what happens is, for example, often people are looking at to classify habitat in an area. Certain, nuanced things like whether the egg cases were present can often get missed. So unless people are looking for it, it's not always recorded, or it might just be buried in a database somewhere. So we're hoping that the more papers we can get out showing the importance of this, then you might start to hear people go, oh yeah, I've seen that before.
Yeah,
because if someone doesn't know, sometimes you find things and you've got no idea whether it's relevant to someone else. Like we see invertebrate stuff sometimes and you'll mention it to an invertebrate taxonomist and they're like, oh, that's incredible, and you're like, oh, okay. I didn't know that.
Yeah, you can't specialize in everything. And before we sort of get onto fully automation and AI, like just by making these databases more accessible, there's an amazing community that have sprung up just online of just interested individuals who are raking through all this old ROV footage and all this old camera footage for little nuggets, the deep sea squids and things like that, things you could never plan a survey around. You'd never go looking for them. But once you gather all these incidental observations, something comes out of the mist, really.
Yeah, definitely. Yeah, I think that's it. And then once you start to collect that information, then absence becomes just as important as presence in some cases. Whereas if you've only got really small data sets, then absence just means that you haven't seen it. It doesn't mean it's not there. So as it starts to piece together, your presence absence information starts to become more, a bit clearer and, more relevant.
Absolutely. And what about the actual reproduction itself? It was when you were visiting over here, that was my first shot to properly look at some alar spines and trying to visualize how that might be useful.
Yeah, so one of the things that I guess rays in general have a little bit more difficulty with compared to sharks is that, often you see, not all sharks, but a lot of sharks have generally sharp pointed teeth. But then when you think of a lot of stingrays and things like that, they've got two things. They often got flatter teeth, and they've also got slippery discs on, the actual pectoral fins forming that sort of circular disc. So, if a male has got to sort of try and find a way to grip onto the female to mate, then that's going to cause, various issues. So the stingarees that I said I worked on during my honours year, one thing that they had was sexual dimorphic dentition. So as the males matured, they developed really long cusps on their teeth, and skates do the same thing. So the males get really quite pointed teeth, and that's purely for grabbing onto the females to mate. They don't develop those until they're maturing, and there's been studies that show there's no differences in diet between the males and the females. It's purely about reproduction. But then with skates, yeah, they have these thorn patches develop on their pectoral fins. They have these, they call it an alar patch and a malar patch, which can develop on the side. And they're actually quite lethal for collection workers when you're handling them, because they're the sort of spines that they sort of direct inwards towards the middle of the animal. They don't come up much from the surface and then they hook straight over and point inwards. So if you run your hand one way, your hand would just glide over them, but you go the other way and you have these, sometimes up to a centimetre long thorns embedded in your hand. So we sort of call them glove killers, because they're really good at putting holes in your gloves without realising it. But yeah, they use those to grip onto the female, so it enables them to sort of hook on while they're trying to reproduce. So yeah, that's one of the most interesting things, is that they often have these sexually dimorphic characters to distinguish them. And the actual claspers of males, they sort of splay open at the end, which sort of helps them sort of get grip in the cloaca of the female as well. And the morphology of the claspers is actually an extremely important taxonomic character for skates. So it is a good taxonomic character, but it's a terrible one if you don't catch a male.
Yeah, it's only there half the time.
Yeah, that's it. Or even less than half the time, because it has to be a mature male too.
Okay,
so,
yeah.
So it's a small percentage of the time, unfortunately. But yeah.
But brilliant character where it's there.
Yeah, that's it.
Any sort of key differences in the deep versus shallow species? What's some characters that make them equipped for the deep?
Well, certainly within skates, not really. I mean, you get darker coloured, much more that sort of typical deep water species kind of eye colour. You get that sort of bright iridescent green sort of eye when they first come up. Shallow water ones usually are a bit paler, and yeah, usually that sort of slightly more browner and paler sort of colour. But other than colour, not really a lot. You do get more of the soft-nosed skate species in deeper waters, and they do look quite a bit different. So it's hard to know what's just taxonomic. But no, in general, they're quite a similar body plan, shallow and deep. Like even the one that I said that occurs in the harbour here, if you showed that to someone, you'd be like, oh, that's a deep water species. They're like, no, it occurs in less than 10 metres in a harbour.
Yeah, I struggled on this question actually, because it works. As long as it's not too deep, that body plan works.
Yep, that's it. There's over 250 odd species, so it's a very efficient body plan.
On the back of that, we've got an artist listener, very much on what color they are, any patterning or textures to the skin, and whether they're dark on top and light on the bottom, like we tend to see. I know some of the deep ones go pale all over. It isn't super consistent on light underneath or not.
Yeah, it is really all over the place. Some species are jet black on the bottom and light on the surface. There's a few that are light on both surfaces, and it doesn't seem to really go with depth. Some species are just really light. So whether there's any form of trying to mimic things or blending in certain ways, you really don't know. But yeah, they really cover everything. There's some that have the big ocelli on each pectoral fin. So whether that's to make them look like something bigger than what they are to a potential predator swimming over.
Yeah, big obvious eye spots. Then some of those are quite beautiful. They're quite,
yeah.
Some of it's lost within the mottling, and then there's a big eye spot there as well. And then sometimes it's really a standout eye spot.
And what's interesting is some of those, and in quite a lot of the colour pattern in some of the skates I've seen, is they have a layer of mucus on them. And sometimes part of the colour pattern lies within that mucus.
Oh, wow.
So if you wash all that mucus off, there's all these little white spots, for example, that can leave, they can fade away, and you almost wash them off. And I came across that first with an angel shark early on here, where I thought I better clean all the mucus off, and cleaned it off, and then sat back and went, oh, the spots are all gone. So it's really hard though, because if you freeze the animal, the mucus turns all horrible and slimy. So it's really important to get fresh photos. But yeah, and I remember seeing a blue-spotted fantail ray when I was diving in Indonesia once, and the way the light was hitting it and the fact that I came onto it quite low down, right near the bottom, the blue spots almost looked three-dimensional, almost looked like a coral.
Whoa.
It was really incredible. And I think that there's something about that with the colour that lies in the mucus versus colour in the skin, is I think there's almost a three-dimensional. So it's not just like, oh, it blends in, but I think it almost looks textured.
Yeah.
So much what like a cuttlefish does with its skin, is I think that's what that sort of colour pattern does. But there really is a wild diversity of colour patterns. There's even a blue one in Australia that's like this extremely bright blue, like amazingly bright blue, and then really dark on the ventral surface. There's some that are almost white. on the dorsal surface and almost black ventrally. The ones that are black ventrally, it sort of does indicate that they potentially swim off the bottom a bit, and that sort of allows that bit of counter shading sort of thing. But yeah, it's really hard to generalize with color patterns in the skates. They're just so diverse.
Oh, here's just a nice alley-oop. What's your favorite?
I'd say probably that blue skate I was mentioning before. The bright color of it is just amazing when they are fresh. That sort of color that you just want to keep looking at, just a nice color, almost like the purple Pantone color of Cadbury's chocolate makes you want chocolate, but their thong's just a beautiful, beautiful blue. So I reckon that has to be one of my favorite. The other one is there's a type of electric ray that you get in South Africa called Electrolux is the name.
Sounds like an excellent product.
Yeah. It has these yellow spots all over it, which just look phenomenal. Like it looks like something that's been completely made up. Between that and the freshwater stingrays you get in the Amazon, which look amazing as well.
Oh, they are incredible.
Yeah. They're probably some of the most beautiful ones. But I don't know, I've got to admit, I always find it hard calling favorites because, it's not that I don't have a favorite, but it just changes so regularly. Yeah,
it's whatever you're working on.
Yeah, that's it. And sometimes you're so sick of the paper that's finally got published that the last thing you want is them to be your favourite species. So yeah, it does chop and change a lot.
Yeah, if you can't stand to look at it anymore, then the paper's ready.
Yeah, exactly.
On the back of that, were there any standout species with super specific adaptations, maybe for temperature, oxygen, unusual hunting methods?
Yeah, well, I'd say I do like the big smooth rays that we get, mostly in southern Australia. I think you get them in New Zealand as well, actually, the Bathytoschia brevicordata. You sometimes see them in really shallow water, over 2 meters wide. And I used to work in an aquarium in Perth, and they do seem like big floppy blob of animals come up and try to get food off you as much as they can. But then every now and then one of these big ones would be able to corner a big skipjack trevally. It could be like 4 kilo fish and manage to pin it down and eat a whole one of those.
That's what I've seen, them pinning them on the glass.
Yeah, and they used to. So I've got a soft spot for them, and they were quite cheeky animals. They can actually flex up their spine, and the spines on those things are amazing. Like you could hammer a nail in with them; they're incredible. You would not want to get hit. It'd easily go through bone, and you couldn't just keep feeding them because they'll just get ridiculously overweight and they get bloated livers, which isn't good. Every now and then, if you stop feeding them, you just kind of push them away, and every now and then one would swim past and it would like flex its spine and just like drag it across like the back of your hood on your head or something, like almost like a threat.
Just reminding you. Yeah.
And it's just like a reminder. And more often than not, they did end up getting another fish after that. It's like, no, stuff it. You can get overweight. Yeah. I'm not getting spined. So
coming up with priorities. They're really, really smart. I used to work in an aquarium with a load of the freshwater ones, and they recognized the uniform of the staff who were working there. So I think they recognized individuals as well, but they would respond to the uniform. And so they're just ignoring members of the public, and then a red shirt walks past and it's that up against the glass, la 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 la, begging.
Yeah, no, it's quite good. Yeah, it's like I've seen cow nose rays do that in aquariums in Japan where they got like coming out. They look amazingly weird when they're sticking their head out the water trying to get to some food.
Trying to look cute with that face.
Yeah, that's it.
Oh, that's amazing. And yeah, just as the final one to give you an opportunity, is there any piece of information you'd like the general public to know, or is there any piece of misinformation that is constantly getting bounded around you'd like to put a stop to?
I think one thing that's always good to let people know about is a lot of the work we do on egg cases has become quite important because they are quite species specific, but just getting hold of samples can be hard. So in the UK, the Shark Trust started this great egg case hunt project many years ago, and it is a global, like you can enter them anywhere in the world, but we just recently set up a load of identification guides for the Australian ones so that people in Australia can start recording. But it'll be a great one for people to start picking up more internationally as you go beach combing, you find these egg cases, and just to have them reported. We start to find areas where these animals, might be really important breeding areas. Like you don't get exact locality information from a washed up egg case, but on the other hand, it's not like they would have travelled for weeks. So if you get a lot of Port Jackson shark egg cases in one area, for example, then there's a good chance they've probably got breeding populations around there. And, once we start getting more and more information coming in, I think we'll start to get some good. So it's a really good citizen science project. So yeah, I think that's probably one of the things that'd be good for, people to get on board and have a look at. And you can get onto the Shark Trust app on any Android or iPhones and download that. And a project within that is the Great Egg Case Hunt, or just have a Google of it. It's good and it's great, especially for young kids getting involved in recording data that can be used for scientific studies later.
Oh, that sounds super useful. We'll put in our show notes all the links to that to get you started.
Yeah, no, thanks for that.
Oh, that's a really good one to end on. We'll put everything we can find in the show notes if you want to get involved. Well, thanks for your time, Will. That was really good fun. I actually learned a lot. I always do, though.
Thanks for having me on. It's been really good.
And that was a pressurized version of one of our longer episodes. If you enjoyed that and you would like to hear the full length episode, just match the episode numbers and you'll be able to find the full length version in the feed. Thanks for listening. We'll deep see you next time, and I abyss you already.